All right, now these examples, this is where domain and range gets a little trickier because on the first four examples, they were all just points, and so we could just list x and y values. But here when it's a line is an infinite collection of points. So we'd never be able to write down every single x value and every single y value. So we need to be able to write it symbolically. So that's kind of where the difference is and where the difficulty is going to come in now. So for my domain, I'm just going to go left to right, and I just kind of come along, and the first place that I get a point is at 0. And then if I look, the domain, this graph just keeps on going to the right forever. So if you think about points on the line, so I'm making these little blue points on the line, this just keeps on going and going, and I keep getting x values to the right. So the domain starts at 0 and it goes forever, basically. We could say all the way to infinity. So one way of writing it is to write it as a range, and the way we write that is it's always from left to right where it starts and where it ends. A 0 is less than or equal to x is less than infinity is one way of writing this, but probably the easier way, and the way this would normally be written instead, is that as we go to the right, the x values are getting bigger and bigger and bigger. So the domain here is really just all the x values that are greater than or equal to 0. Okay, so some people like to write this two-sided and say it starts at 0 and ends at infinity. But again, the simpler way is probably just to write x is greater than or equal to 0. So for the y values, though, I'm going to kind of start at the same point, and I notice that I get y values. This kind of goes up forever. I keep getting y values as I go up the curve. There's y values all the way along. Same thing as I go down, there's all these y values. And because there's arrows, I assume this keeps on going on a diagonal in either direction. So I think this is going to keep on going up forever and keep on going down forever. So my range is basically everything. And how we say that is we usually just say all real numbers. It can also be written symbolically, and symbolically to write all real numbers, it's just these fancy little r with like a double back. All real numbers occurs very frequently, so it's worthwhile just remembering. So for the domain, it'll be all real numbers if a relation goes to the left forever and to the right forever. For the range, it'll be all real numbers if the relation goes up forever and down forever. And now on to f. I'm going to graph this and then find the domain and range. So I'm going to use a program called Desmos, and you can go to Desmos. It's www.desmos.com. This is a program we'll use a lot in this course, and you can use it on tests. It's actually an online graphing calculator. You can use it on your phone, and it's way better than any other graphing calculator. So on Desmos, I'm just going to graph first y equals square root of 3 minus x minus 2. Okay, beauty of Desmos, especially if you're using a phone or something, is that it's easy to graph it, and then right now all I'm doing is pinching the screen and then widening my fingers, and it zooms in and out. All we're really using Desmos for on this one is just to get a sketch of the relation. So it's just important to see that it kind of starts at 3, negative 2, and then it's going to the left forever. So I'm just going to come over to my paper and I'm going to sketch this function starting at 3, negative 2 and heading to the left. And now I can start figuring out my domain and range. Okay, so there's just showing it starts at 3, negative 2. So the domain, I'm going to look at the right and act like it starts at 3. And then I notice I got points and it just keeps on going to the left forever. So it starts at 3 and it goes to the left forever. Well, as you go to the left, you get smaller and smaller x values. So then the domain is x is less than or equal to 3. So less than because the x values are getting smaller and smaller. My range starts at negative 2, but it's going up forever. So what I know about that is as I go up, I get bigger and bigger y values. So all these y values are bigger than negative 2. So the range is y is greater than or equal to negative 2. And there I have these two examples done.